So method of joints. So among the methods of analysis of truss, we are starting with the first method, that is method of joints. So these are the following points that are important in method of joints. So the first point is to draw the FBD. So what is the full form of FBD? Free body diagram. So free body diagram or FBD for each joint is to be drawn. Second is use two conditions of equilibrium. Use two conditions of equilibrium. Sigma fx is equal to 0 and sigma fy is equal to 0. Now whatever the joint you are selecting, that joint selected should not have more than two unknown forces. So joint selected for drawing FBD should not contain more than two unknown forces. More than two unknown forces. So maximum there should be two unknown that should be present at a joint. As there are maximum two unknowns, hence we are having the two equations, or we can say as we are having only two equations, we can find out only two unknowns. If more than two unknowns are present, then we won't be able to find out the forces. So first step in this method is to find out reactions. Even in method of sections, the first step is to find out the reactions. So if you don't know how to find out the reactions, you can watch the videos which I have uploaded for finding out the reactions. Now the first step is to find out the reaction. From the second step, we have to consider joints one by one. So one by one we have to consider a joint, and then we have to apply sigma fx is equal to 0 and sigma fy is equal to 0 on each joint. On each joint you have to apply this formula, or we can say this condition. Now what are the sign conventions in this? So in overall truss we will be using the same sign conventions, that is we will be using tensile or tension as positive and compression as negative. So we all know now tensile means this is the representation, and compressive means it is trying to compress the member. Okay, so these are all the important points in method of joints. So what is the first point? We have to draw the FBD for each joint. Then we have to use the two conditions of equilibrium, sigma fx is equal to 0, sigma fy is equal to 0. Now whatever the joint we are selecting to draw the FBD, it should not contain more than two unknown forces. Then what is the first step while solving the numerical by using method of joints? First find out the reactions. Then second step is consider the joint one by one and then apply the sigma fx is equal to 0, sigma fy is equal to 0. So now quickly we'll take one example here. So this is the truss. So on this truss, here is one hinge support and here is one roller support. So there is one load which is acting 100 kilonewton and it is present at the, or we can say it is symmetrical. Now what is the first step here? We'll give this height also as 5. This height is also 5 now. Now the first step is to find out the reactions. So this is A, B and C. How many reactions are present at A? It is a hinge support, that means two reactions. How many reactions at C? One reaction. So this is VA, VC, vertical reaction, and horizontal reaction HA. So first we have to find out HA, VA and VC. So what we will do? In first step, reactions find out means we'll use sigma Fx is equal to 0. So that will give us HA is equal to 0. Second is sigma Fy is equal to 0. That will give VA plus VC is equal to 100. The third condition will use sigma MA is equal to 0. So that will give us 100 into 5 is equal to VC into 10. So this VC will be equal to 100 into 5 divided by 10. So this will be 50. So VC is 50. That means VA is also 50. Also we can say directly by symmetry that these both are 50 and 50 as it is symmetrical. So now this is over. That is the first step is completed, finding out the reactions. Now what is the second step? Consider each and every joint. So consider joint A. So how many members are present at joint A? There are two members, FAB and FAC. So for drawing the free body diagram, so pay attention now. First we will draw the joint here. So this is joint A. What are the forces which are acting at joint A? So this VA is acting. So this VA value is 50. Then HA is also acting, that is 0. So we don't have to show it here as it is 0. Now there are two forces which are acting here, FAC and FAB. As there are two members, the two members will have some forces in them. So that forces we have to represent here as FAC. So this FAC and FAB. This is FAB. Now why I have taken the direction as away from the joint? First we will assume one direction, then we will find out the values. If they are matching, then the direction will be same. If the value is coming negative, that means the direction is opposite. So now at this point we have completed the free body diagram for point A. We need this angle. So this angle we can find out by using the tan theta. So here tan alpha is equal to opposite by hypotenuse, that is 1. That means alpha is equal to 45 degrees. So this is 45 degree. Now in this free body diagram, you have to apply sigma Fx is equal to 0 and sigma Fy is equal to 0. So if you apply sigma Fx is equal to 0, it will be FAC plus FAB cos 45 is equal to 0. And in sigma Fy is equal to 0, it will be 50 plus FAB sin 45 is equal to 0. So if you solve these two equations, you will get the value of FAB and FAC. Now this is an inclined force, okay, FAB. So this inclined force you can write it as a component of two forces. So this horizontal component is called as FAB cos 45 and this vertical component is FAB sin 45. So instead of writing FAB now, we can write here FAB cos 45 and FAB sin 45, and then you can apply these two equations. Okay. So in the next video now, we will solve one complete problem. As you are seeing here that we have considered joint A, so we will get FAB and FAC. That means this force and this force we will get. Now to find out FBC, we will have to take the joint C. So similarly, joint C we will be taking, this is C, this is 50 force. There will be one force which is acting in this side, and this is FAC, and one force in inclined direction, that is FCB. Same thing, sigma Fx is equal to 0, sigma Fy is equal to 0, and then get the values of FCB. I hope it is clear. Now in the next video, we will be solving the numericals.